Okay, so these are the ones that we covered yesterday for basic research, applied research, and technological development. So just a quick review. Anyone remember the 6 types of chemistry without looking at your notes? Biochemistry, analytical, organic, inorganic, theoretical, and physical. Very good. So those 6, the way they are, like we said it, right, those are the ones that are going to be just matching on the test when we have the test over this section, okay? So you just need to know the basic ideas for those types of chemistry. All right, so next one, the one that everyone knows, scientific method. Okay, and I don't know why this is. Different books, for some reason, use different words for scientific method, right? So we'll stick to the ones I got from the chemistry book, right? So you might have seen it a little bit differently. So what is the scientific method? Okay, it's a process to do what? Okay, solve a problem, gain more information.
Is it where you see a situation, you make a hypothesis, test your hypothesis, and then see if it's
Very good. So what was the first thing you said?
hypothesis?
No, before that.
Problem or a theory.
Okay, situation, problem, question, right? How do you identify that situation, that problem? Observations, right? You actually have to see it happening, and then you start wondering or pondering, right? What's going on there, right? Once you have an idea, right, that's when you come up with your hypothesis. And then the next thing that you said after the hypothesis, you experiment, right? And what if your experiment shows that your hypothesis is false? The what?
You make a new hypothesis.
Right. You try a new way, you get a new hypothesis, right? Your first hypothesis isn't always going to be the correct one, right? So one of the things I like using is, let's consider someone that's never used a car before. And they come out to the car, right? And somebody tells them to just turn the key and it'll turn on. They turn the key and nothing happens. They walk outside, they see that the tires are low. So could that be the reason the car did not turn on?
No.
Why not?
The person who's never used a car wouldn't know that.
Exactly. The person that's never used a car wouldn't know that. So you automatically said that's not the case. Why did you say that? Right, get background information. So when we're talking about a hypothesis about why something didn't happen, what's another thing that they use when they talk about hypothesis? What's another word that they use when we say we create a hypothesis? Educated guess, right? That educated is because you have that background information, right? Obviously, we know it's not because of the tires, right? So if it doesn't make any noise at all, what do you think it could be? The what? The battery, right? If it doesn't make any noise whatsoever, right, that means it's got no electricity going through it. Could it be that the gas is low? No, because again, it would still try, right? It would still turn over. It just wouldn't do anything because there's no gas there, right? So when we're talking about scientific method, right, we have to have at least some background information. We have to be able to come up with that educated guess, okay? So again, this is a way of solving problems, right? We call it a formal and time-tested method to solve problems. What do we mean by formal?
Like a
Plan, right? Do we have certain steps that we follow when we're doing scientific method? Yes, right? That's all we mean by formal, that there's steps that we follow. Time tested, right? Has this been used for a long time? Yes, right? And it does seem to work. Okay? That's all we mean by those two things. It's a set of steps that we follow, right, to solve these problems, right? Even though we call it scientific method, do we use scientific method to solve other problems besides the ones in science? Right? Do we think about it? Hold on, let me write down my first observations, my hypothesis, all this other stuff. No, right? But this is what we followed in the example of the car, right? That's what we would follow. Now, back to the car example, my grandfather used to do this, right? Not exactly the safest way you're supposed to do this, right? When he thought there was a problem with the battery, he'd get this really long screwdriver, he'd touch one terminal and touch the other one. And if it sparked, he said that the battery was okay. Later on, I found out when you do that, you could actually make the battery explode. So please, never try that. There's gases inside that battery, and that spark could make it blow up, okay? I didn't know at the time. I just thought, oh, my grandfather's cool. Look at all those sparks being caused there. All right, so let's go through each one of these steps. All right, the first one that was mentioned, observations. All right, so observations, recorded facts. Why do we have to stress recorded facts? What's the problem when we're writing things down? What could people write down instead of facts? Opinions, right? When we're dealing with observations, all we're dealing with is facts, right? We're not trying to make any guesses yet. We're not going to put in our opinion. All we do is write down the facts that we get from whatever natural phenomena we're dealing with. Right? A natural phenomena is just something that happens. Are we okay with this? All right. So after we get our observations, right, now we come up with our hypothesis, that educated guess. Okay, so for hypotheses, descriptive models used to explain the observations. Okay, all we mean by descriptive models is you've seen things before, right? Again, we have our background knowledge, so we're trying to fit what we just saw into these models that we've created in our heads. Right, that's what we mean by descriptive models used to explain the observations. And again, these are referred to as educated guesses because we're trying to fit what we just saw, our observations, into what we've seen before. All right, once we have our hypothesis, what do we do next? We test it, exactly. And the way we test it is we do experiments. All right, so experiments used to prove or disprove a hypothesis. Again, your hypothesis might not always be right, so that's why we put in that disprove. By controlling one more conditions. If we disprove our hypothesis, is that still giving us data to work with? Right? We got rid of one of the options. Well, what are some of the other options I have available? Right? If we check the battery in the car and the battery's okay, right, then okay, we get rid of that hypothesis, we can go on to something else. Figure out what else could be causing the problem. Okay, now these next two slides are not part of the scientific method. They are all part of experiments, right? Because what does the experiment provide us with? The what? Data, right? So these are the types of data that we're going to come up with, okay? Qualitative data. What does that give you? What word do you think we can get from qualitative data? The quality, right? What would be the quality of the paper that we used the other day? Okay, it was smooth, rectangular, right? So basically, when we're talking qualitative data, we're talking about stuff that would describe what we were working with. So again, for your lab report, I asked you to describe the paper, right? So you would be providing qualitative data, right? So information that describes color, odor, shape based on the 5 senses. Okay, how do we see color? Okay, light with our eyes, right? Going with the senses part, right? So we use our eyesight for that. Odor? Our nose. And how do we get odor in a chemical experiment? Wafted, right? Wafted towards ourselves. Shape, again, something that we would see. What is the one sense that we normally don't use in the lab? Taste, right? We will never taste a solution to check if it's an acid or a base, right? We don't do that. Okay? But basically, most of the other senses. Okay? We would be using that. So that would be qualitative data. What do you think the other type of data is going to be? Quantitative data. And it's going to give us what? Numbers, right? Quantitative, it's going to give us a quantity. So that's the one that's going to give us numbers. Sorry, I forgot about the examples there. Heavy, cold, warm, blue, shiny. Those would be qualitative. So quantitative data, numerical information includes number and unit. Again, anytime you write a number, you should always include a unit. So the numbers that you took off the balance, what units were those in? G, which is grams, right? So you can put the G or you can write out grams, either one, right? It's understood. So examples of that would be, for example, 100 grams, 45 inches, 98 degrees Celsius, right? All those have a number and a unit associated with them. Okay, are we okay with this? Again, all this is just part of that experiment section that we're talking about for scientific method. Okay, next thing. Oops, sorry. I guess I forgot to put the transition on that one, right? So, 3 types of things that we look at for an experiment. Independent variable, dependent variable, and our control. All right, so independent variable, condition that you plan to change or control. So what are something that could be considered an independent variable? Huh?
How much we give in, like food, like.
Okay, so how much food, right? Or if we're doing an experiment, if you're using a certain amount of water, what could be the amount of water? What units could we be using for the amount of water? Milliliters. What else? Okay, liters. So both of those are units for volume. Besides volume, what else could we measure the water in? Grams, right? We could say so many grams of water. Okay. So we can control the mass. We can control the volume. Can we control time? Okay, this is the one that people aren't sure about, or they say no right off the start. Well,
You can time it, but you can't.
exactly. So if you have a stopwatch, you can control how long the experiment is for, right? Obviously, you can't bend time or anything like that, right? But you can control the amount of time an experiment runs for, okay? So it's possible to control time, but we're just talking about the length of the experiment, not the actual time itself, right? So that would be independent, right? Dependent are things that change because of that, right? For example, the mass of the paper, right? Did it remain the same during the experiment that we ran?
No.
No, right? So that was dependent in that case. The mass of the paper was actually a dependent variable because it changed when we started burning it. Okay. And finally, a control is a standard for comparison, right? We know what happens in this case. Well, what if we change certain things? How will it compare to that original experiment, right? To that initial observation. So that's what we mean control. So that's why a lot of experiments that you hear about, like weight loss or this or that, they always have some type of control, right? That they're comparing the people to. Does anybody know, like when they're trying to use like diet pills or something? They give one group diet pills. What do they give the other one?
Placebo.
The what?
Placebo.
A placebo, right? Basically, it looks exactly the same as the pill that they're giving the other people, but it normally is just sugar or something else, right? So that would be the control because they're actually not giving them anything extra, and they're going to compare it to these other people, right? Now, if a change happens to the people with, right, that are getting the placebo, then they refer to that as the placebo effect because they think they're getting something, so they must be going through some type of change, right? They're going through psychological type things, right? So when they're eating, they'll actually go, oh, I feel full, I must stop because I'm taking that placebo. So psychological type things when you're dealing with that. All right, so those are the three things that we look at when we're dealing with our experiment. Okay? So now let's go back to what that information is called. Somebody used this term before, right? All this that we're looking at is the data from the experiment. Okay? Again, all this is part of that experiment. Okay. So again, this just goes with the experiment part of our scientific method. Right? Again, for the data, it could have been qualitative, it could have been quantitative. Right? That data could be our independent variable, our dependent variable, or the data from the control. Right? All this is part of the experiment. So using this data, right, these observations recorded from an experiment, we can use to either prove or disprove the hypothesis, right? As we mentioned before, if we disprove the hypothesis, we just get rid of that hypothesis and get a new one. Now, what if our hypothesis is proven? Then what? This is the next part of the scientific method. A what? A theory. Okay, now does it only have to be proven once? No, it has to be over and over again. Are you the only one that's going to prove it? No, it has to be a lot more other people for it to become a theory. Right? For example, on the periodic table that I have up here, right, there's some missing. Right? All these, though, on your periodic table that I gave you, all those are full. Right? The what? No. They are available now. They've been formed. The only thing is, it took a long time because one set of scientists created it, right? But they were the only ones to do so. So people were not believe them. Scientists wouldn't believe them until other scientists were able to do the same. Okay? Have you ever heard of cold fusion? Okay, fusion is what happens in the sun, right? We can't do fusion here on Earth because it requires such high temperatures. So that's why they talk about cold fusion, where we could do it at a colder temperature than the sun, do it here on Earth.
Sorry.
Supposedly, one set of scientists have done it. Supposedly because no one else has been able to recreate it. So that's not an accepted experiment yet.
Why aren't other people?
The what?
Why aren't other people able to?
Well, because they said they did it, but they haven't been able to show other people. So that's the thing. Not until it's been proven, right, several times by several different entities, right, could we go from a hypothesis to a theory. It's like, really, it worked that one time. That's where we're at that point for cold fusion. All right, so once the data proves our hypothesis, then finally we can come up with our theory. Okay, so theory, a thoroughly tested model. So again, multiple entities have to be able to do the experiments, right, to prove the hypothesis so it can become a theory. That explains why an experiment gives certain results. So the theory then can be used to predict behavior of natural systems under different conditions. Now that we know why things happen, well, what if we change this? We should be able to predict what different changes will occur by changing one thing or the other, changing the independent variables. Okay, and the main thing I want you to see on theory, because we're going to see something else in a bit, theory, the main thing about it is explains why an experiment does what it does. Okay, that's what a theory does. It's the explanation, because there's one that's slightly different that's part of the scientific method as well. All right, so we start off with observations. All right, it's up to you if you want to write this down or not, but just want to put these all together. We've got observations. Our observations are going to lead to what? Hypothesis, right? Once we have our hypothesis, what do we do next? Right, we do our experiments, right? And then what ends up happening is the experiments are either going to prove or disprove your hypothesis. If it disproves your hypothesis, what do we do next?
If it disproves
It disproves.
Make a new hypothesis.
Right, you create a new hypothesis, right? And finally test it again, and eventually what's going to happen is if we can prove our hypothesis over and over again, then that's going to lead us to our theory. Okay? So again, when we come up with our hypothesis, it's what we think is going to explain the experiment, the natural phenomena, and then it finally, if proven, that becomes a theory. All right, so getting this little mole here, though it's missing its paws. By the way, you will be making this for October 23rd. You'll be making a mole if you haven't heard about it yet. All right, so let's consider the following. See if this follows the scientific method. What goes up must come down. Is that a theory?
No, that's a law.
It's a what? That's a law, right? What goes up must come down. We're not saying why it does it. We're just saying that it does. So scientific law is part of the scientific method, but it's a separate thing, right? So these steps that we see is to get to a scientific theory, right? Scientific law, what happens is we observe something, we do the experiment, happens over and over again, right? So that's different from a theory. Theory, we try to explain it. Law, we just say that it happens. Okay? So when we're dealing with a scientific law, a concise statement, for example, what goes up must come down, right? Okay, so comparing theory to scientific law, right? They both have observations. But for a law, we go straight to experiments. We don't come up with the explanation. We don't come up with the hypothesis, right? Once the experiments have been done over and over again, everyone gets the same results, then we've got a scientific law. Okay? We're not trying to explain it. We just say that it happens. It's okay, we'll stop here for today.